July 9, 1952, 6:15 in the morning. A Lockheed L-049 Constellation sits on the ramp at Los Angeles International Airport. The aircraft registration reads N86511. Trans World Airlines Flight 6 to New York Idlewild. Captain William Harrison completes his walk-around inspection, moving along the curved fuselage, examining the distinctive triple-tail configuration that gives the Constellation its unmistakable profile. The aircraft measures 95 feet 2 inches from nose to tail. Wingspan, 123 feet. The fuselage curves downward toward the tail, a dolphin-like shape designed to accommodate the pressurized cabin structure while maintaining aerodynamic efficiency. First Officer Thomas Reed inspects the port wing, checking the 4 Wright R3350 duplex Cyclone engines. Each 18-cylinder radial produces 2,400 horsepower at takeoff. Each weighs nearly 3,000 pounds. Flight engineer Paul Brennan examines oil levels, checking each engine's reservoir. The Constellation requires constant attention to engine temperatures, fuel mixture, and propeller synchronization. 3 crew members in the cockpit. Standard for complex piston operations. Morning preparation. Inside the cockpit, the instrument panel extends across both pilot positions in intricate detail. Airspeed indicator, dual altimeters, rate of climb, artificial horizon, directional gyro. Engine instruments clustered for the flight engineer's monitoring. Cylinder head temperatures, manifold pressures, oil temperatures, fuel flow. The Constellation's cockpit sits high above the ground. The nosewheel strut positions the aircraft at a distinctive angle, nose elevated, requiring external stairs for crew access. Harrison settles into the left seat. Reed takes the right position. Brennan occupies the flight engineer's station behind and between them, facing a vertical panel crowded with gauges, switches, and controls. The checklist begins. Battery on, fuel selectors, magneto switches, mixture controls, propeller governors. The Constellation carries 4,200 gallons of fuel distributed across wing tanks and auxiliary tanks. Range, approximately 3,000 miles under optimal conditions. The Wright engines, each R3350 engine represents the pinnacle of radial piston technology. 18 cylinders arranged in 2 rows of 9. Supercharged for high-altitude performance. The engines rotate counterclockwise when viewed from the cockpit, their massive 3-blade propellers measuring 13 feet 6 inches in diameter. Brennan initiates the start sequence for engine number 3, port inboard. The procedure is precise, methodical. Fuel booster pump on, primer engaged, starter switch. The propeller begins to turn. Slowly. The engine coughs once, twice, then catches, firing in sequence across 18 cylinders. White smoke billows from the exhausts, dissipating quickly in the morning air. The sound is unmistakable, deep, powerful. The mechanical rhythm of pistons firing thousands of times per minute. Engines 4, 2, and 1 follow. 4. Wright R3350s now running, their combined power generating 9,600 horsepower, ready to move 65,000 pounds of aircraft, fuel, passengers, and cargo across the continent. Ground operations outside. Ground crew prepare to board passengers. The Constellation carries 64 in standard configuration. Sleeper berths available on overnight transcontinental flights, though Flight 6 operates in day configuration today. The cabin is pressurized, a significant advancement over earlier airliners. The Constellation can cruise at 20,000 feet while maintaining an 8,000-foot cabin altitude. Passengers experience minimal discomfort at cruise. Baggage loading proceeds through the forward cargo door. Mail and express shipments fill the aft cargo compartment. The Constellation serves dual roles, passenger transport and commercial cargo carrier. Development. History. Lockheed began designing the Constellation in 1939, responding to Trans World Airlines' request for a long-range, high-speed pressurized airliner. Howard Hughes, controlling TWA at the time, personally influenced the design requirements. The prototype first flew in January 1943, but wartime priorities diverted production to military variants. The C-69 military transport served the Army Air Forces, though in limited numbers. After the war, Lockheed converted existing military airframes and built new aircraft for commercial operators. TWA received the first civilian Constellation in November 1945. Pan American, American Airlines, and international carriers followed with orders. The Constellation's performance transformed transcontinental travel. New York to Los Angeles in under 10 hours. Coast-to-coast service without refueling stops. Taxi and takeoff preparation. Harrison receives taxi clearance from Los Angeles Tower. TWA-6, taxi to runway 25 left. Reed acknowledges. Harrison releases the parking brake, advancing throttles slightly. The Constellation begins to roll, its tailwheel configuration requiring careful ground handling. The aircraft sits nose-high on the ground, limiting forward visibility during taxi. Reed monitors from the right seat, watching for other aircraft and ground obstacles. The wingtips extend well beyond the fuselage. Clearance requires constant attention. At the runway hold point, Brennan completes the pre-takeoff checklist. Fuel mixture. Rich propellers. Full forward pitch. Cowl flaps. Open. Superchargers. Low blower. Flight controls. Checked. Trim. Set for takeoff. Takeoff performance. The Constellation requires 95 knots for rotation at current weight. Harrison calculates figures based on fuel load, passenger count, temperature, and pressure altitude. Los Angeles runway 25 left measures 8,500 feet. Adequate for the Constellation's requirements. Tower clears Flight 6 for takeoff. Harrison advances all 4 throttles to takeoff power. 54 inches of manifold pressure, 2,800 revolutions per minute. Brennan monitors engine instruments, calling out any deviations. The Constellation accelerates. 60 knots, 75 knots, 90 knots. Reed calls speeds. Harrison maintains directional control with rudder and differential braking, keeping the aircraft aligned with the center line. Rotate. Harrison applies back pressure. The nose lifts. The main gear remains on concrete for another moment before the wings generate sufficient lift. Gear retraction. Reed raises the landing gear handle. The main wheels and tail wheel fold upward into their wells, reducing drag. The Constellation climbs at 800 feet per minute. Departure from Los Angeles. At 2,000 feet, Harrison turns eastbound, following the departure corridor. The morning sun illuminates the San Gabriel Mountains ahead. Flight 6 will climb to cross the mountains, then descend into the Mojave Desert before beginning the long crossing toward the Midwest. Brennan manages power carefully. The right engines run hot. Cylinder head temperatures require constant monitoring. Too hot, and the engines risk detonation damage. Cowl flaps adjust to control cooling airflow. Propeller synchronization is critical. 4 engines running at slightly different RPMs create a beating sound in the cabin, uncomfortable for passengers. Brennan adjusts each engine's RPM individually, bringing them into harmony. Climb to altitude. The Constellation continues climbing through 10,000 feet. Brennan manages the transition from low to high blower on the superchargers, maintaining manifold pressure as the aircraft ascends into thinner air. At 18,000 feet, the crew switches to standard altimeter setting. All aircraft above this altitude reference the same pressure datum. The cabin pressurization system maintains comfortable conditions inside. The differential pressure between cabin and outside air increases as the aircraft climbs. Structural limits restrict maximum differential to 5 pounds per square inch, adequate for maintaining 8,000-foot cabin altitude while cruising at 20,000 feet. Outside, the landscape transitions from coastal mountains to desert. The Colorado River appears ahead, marking the boundary between California and Arizona. Cruise configuration at 20,000 feet, Harrison levels the aircraft. Brennan reduces power to cruise settings, 36 inches manifold pressure, 2,200 revolutions per minute. Fuel flow decreases. The Constellation settles into efficient cruise. Airspeed, 280 miles per hour. Fuel consumption, approximately 350 gallons per hour across all 4 engines. The flight plan calls for eastbound routing across Arizona, New Mexico, Texas, Oklahoma, Arkansas, Tennessee, and into New York. Total distance, approximately 2,400 miles. Flight time, 8 hours, 30 minutes, including 1 refueling stop in Kansas City. Engine management in Flight Brennan's role is critical. The Wright R3350 engines demand continuous attention. Each cylinder head temperature gauge shows individual cylinders. Hot spots develop if fuel mixture runs too lean or cooling airflow becomes inadequate. Oil consumption requires monitoring. The engines burn oil during normal operation. Brennan tracks consumption rates, ensuring adequate reserves for the entire flight segment. Fuel management involves transferring fuel between tanks to maintain proper center of gravity. The Constellation's fuel system allows selective feeding from different tanks, balancing weight distribution throughout the flight. Cockpit operations. Harrison and Reed share flying duties, alternating control to maintain alertness during the long transcontinental crossing. Navigation relies on radio range stations, visual landmarks, and dead reckoning. The Constellation carries no weather radar. Pilots avoid thunderstorms by visual observation and by coordinating with other aircraft and ground stations for weather reports. Communication with air traffic control occurs at regular intervals. Position reports transmitted at designated checkpoints. Altitude assignments coordinated to separate eastbound and westbound traffic. The passenger experience. In the cabin, passengers settle into comfortable seats arranged 4 abreast in first class, 5 abreast in coach. The Constellation's cabin is wider than previous airliners, providing more shoulder room. The pressurized environment allows normal conversation. Engine noise penetrates the fuselage, but at levels lower than unpressurized aircraft. The sound becomes background texture rather than overwhelming intrusion. Stewardesses serve breakfast. Hot meals prepared in the galley, served on china with linen napkins. The level of service reflects the era's standards for air travel. Large windows provide expansive views. Passengers watch the American Southwest pass below. Desert landscapes, mountain ranges, distant cities. Midpoint operations. 3 hours into the flight, the Constellation passes over Amarillo, Texas. Fuel consumption tracking as planned. Engine temperatures stable. All systems operating normally. Brennan calculates remaining fuel. The aircraft will arrive Kansas City with adequate reserves for the planned refueling stop. The stop is necessary. The Constellation's range allows non-stop transcontinental flight under ideal conditions, but airlines schedule fuel stops to maintain safety margins and accommodate payload requirements. Kansas City approach is 90 minutes ahead. Descent to Kansas City. Harrison begins descent from 20,000 feet. Brennan reduces power gradually, monitoring engine temperatures during the transition. Rapid power reductions can shock-cool the engines, causing thermal stress on cylinder heads. The descent profile is planned to arrive at the airport traffic pattern altitude with appropriate airspeed and configuration. Through the windscreen, Kansas City appears on the horizon. The Missouri River curves through the landscape. Municipal Airport sits north of downtown. Air traffic control vectors Flight 6 into the landing pattern. The crew configures the aircraft, landing gear down, flaps extended to approach setting. Landing in Kansas City. The runway threshold passes beneath. Harrison reduces power, initiating the flare. The Constellation's landing technique requires precise speed control. Too slow, and the aircraft sinks rapidly. Too fast, and the landing roll extends unnecessarily. The main gear contacts the runway. The tail settles. Harrison applies wheel brakes, controlling deceleration. The Constellation rolls out, slowing to taxi speed. Ground crew direct the aircraft to the passenger terminal. The engines remain running during the quick turnaround. Fuel trucks position alongside. Passengers deplane for the brief stop. New passengers board. 35 minutes on the ground. Then, clearance for departure. Second leg, Kansas City to New York. The afternoon departure follows similar procedures. Takeoff, climb to altitude, cruise at 20,000 feet, engine management, navigation tracking. The landscape below transitions from plains to forests. The Mississippi River, the Ohio River, the Appalachian Mountains rising ahead. 4 hours into the second leg, New York approach control contacts, Flight 6. TWA-6, descend and maintain 8,000 feet. Harrison begins the descent. Brennan manages power. The Constellation descends through layers of afternoon haze, approaching the eastern seaboard. Approach to Idlewild, Long Island appears below. The Atlantic coastline, Idlewild Airport, opened in 1948, replacing LaGuardia as New York's primary international airport. The crew configures for landing. Gear down, flaps extended, airspeed reducing to final approach speed. Harrison flies the visual approach, following vectors from approach control. The runway extends ahead, long and wide, adequate for the Constellation's landing requirements. Final landing. The threshold passes. Harrison reduces power. The flare. Main gear contact. Tail settling. Smooth deceleration. Flight 6 completes its transcontinental journey. Los Angeles to New York via Kansas City. 8 hours, 37 minutes total elapsed time, including the intermediate stop. The Constellation taxis to the gate. Brennan initiates the shutdown sequence. 4 right R, 335 O's wind down, their 18 cylinders ceasing their rhythmic firing, propellers coasting to a stop. The Constellation's place. The Lockheed Constellation represented aviation's transition from pre-war technology to modern airliner design. Pressurized cabin, long range, reliable performance, elegant aesthetics. The aircraft served commercial aviation from 1945 through the early 1960s. Variants included the L649, L749, L1049, Super Constellation, and L1649 Starliner. Each iteration improved range, speed, and capacity. But the Constellation's era was brief. Jets entered service in 1958. By 1960, the Boeing 707 and Douglas DC-8 dominated transcontinental and transatlantic routes. The Constellation's operating costs couldn't compete with jet efficiency. Airlines retired their Constellations through the 1960s. Some served in cargo operations, others went to smaller carriers. A few survive today in museums and as warbirds. Form and function. The Constellation's beauty derived from functional design requirements. The curved fuselage accommodated pressurization loads. The triple tail provided directional stability and rudder authority. The dolphin-like profile reduced drag. Every line served aerodynamic or structural purpose. The result appeared elegant because the engineering solved problems efficiently. This is why the Constellation remains celebrated, not for nostalgia, but because its design achieved grace through precision. Evening at Idlewild. The sun sets over New York as passengers deplane from Flight 6. They've crossed the continent in a single day, a journey that required multiple days by rail just a decade earlier. Inside the cockpit, Harrison, Reed, and Brennan complete their paperwork. Flight logs, fuel consumption records, maintenance write-ups for any discrepancies noted during the flight. The crew will rest tonight. Tomorrow they'll operate the return flight to Los Angeles. Continuity somewhere. At this moment in 1952, another Constellation climbs out of San Francisco bound for Honolulu. Another descends toward Chicago after crossing from the west. Another loads passengers in Paris for the Atlantic, crossing to New York. The Constellation's operational life will continue for another decade. Then the jets will take over, flying faster, higher, more economically. But the image persists. The triple tail, the curved fuselage, the four radials, the shape that defined an era when airliners were still designed with slide rules and wind tunnels, when beauty emerged from solving aeronautical problems with precision and care. The aircraft that made transcontinental flight routine while looking like a work of art doing it.